Here I am.
How are you?
Fine. Where's everybody else?
The only two people that are important right now are you and me.
Apparently. Probably because I'm
Well, it's
still,
also I did the chime change again.
yeah,
Just because I just feel like I'm rushing through to get done in 45 minutes, and
right.
I'd rather just take a little longer and they can catch up on the video. Or I got a lot more people calling me now, which is always a good thing.
Oh, that's good.
Yeah.
That's
If
good.
I get everybody just to do what the template says to do, we'd be hitting home runs.
Yeah. Well, I agree, but
That's all right.
that's okay. Works for me.
Works for me too.
Yeah, this is
I will
nice.
never do what I did this week again, though.
What'd
That's
you
what.
do?
Oh, and there'll never be four assignments in 1 week.
You did what?
There'll never be four assignments in 1 week again.
Oh, well, that would be thankful. We would probably all be thankful for that. Yeah, I have to admit, it was a long week.
It was. It was. It was taking me 5 to 6 hours to finish the grading every day,
Oh, I bet. I
and
bet.
this week will take less than that. So
Yeah. Well, it should be easier. Oh, somebody else popped on.
that's
Good.
Karen. Good evening, Karen.
Good evening.
How are you?
I'm good. It's cold now. It's actually nice. I'm from Connecticut, so this is
Oh,
nice.
well, it's been cold for us. It's in the 50s,
I know.
and raining, which is unusual for us, but
Yes, crazy California drivers.
we have this group that comes every Christmas time, Thanksgiving, and I think they usually come back Christmas, and they're called Heavenly Treasures, and they work with I would imagine the best way indigenous people, and they start just making crafts like notebook holders and spoons and purses and stuff like that, and they come to sell. So it's Saturday morning, and Saturday night, I went over and I set up the room that they were getting in. We kicked the youth out. We put them in there, got there, and one of the pastors goes, "Well, they want to." I said, "Oh, that's the first wrong line is they want to." Well, they really want to be outside. It's not supposed to rain. I says, "Are they from California? We're in an atmospheric river." And we already had a freak storm this morning. So they
Yeah.
move all the stuff out there. 30 minutes later, they're rushing the stuff back into the ministry center. I'm like, I tried to warn you. I said when we had a major downpour in the morning. It was only supposed to sprinkle, maybe if that. So it was crazy.
Yeah.
It just was in and out. I think we're free tonight. I think we're free until Thursday. Wait, Wednesday, early
Yes.
Thursday.
I think early Thursday morning it's supposed to rain, which
All
is
day Thursday is supposed to rain, and then a
all
little
day
bit on
Thursday.
Friday, maybe a little on Saturday, and then we're supposed to be done. And I'm like, yay! My grass loves it, especially
Yeah.
since I just put liquid manure on it. So I mean, it's really looking green right now. I look like a green thumb. All
Yeah, this
right,
is
so
overwatering. So
yeah, because it's hard, especially my grass. It's very hard to keep water. It just sucks down to I think 20 fathoms below Earth. So all right, I got 502. We're going to get started. Those of you don't know, the reason why I moved it to 5 was I just have more time and I don't have to rush so much. And if we get done early, we're done early. I can possibly get the everything posted tonight, and then try and get it done tonight when I get home from work, and then you have it tomorrow morning if you want to get started. Some of you already started, done a pretty good job. I didn't have a chance to look at a lot of them because I was so busy doing stuff today. Excuse me. Hold on one sec. Sorry, I had to blow my nose. I was been running a little bit today. All right. So I'm going to kind of go over a few things and we're going to get right into it, ask any questions, so on and so forth. I'm going to share my screen. We're going to get right in the PowerPoint. I'm going to go over last week's stuff real quick. And again, kudos on the discussion board. Very, very impressed with questions and answers that are up there, and you're getting all that done early in the week. And as you notice, your grades, I grade maybe Thursday or Friday for everybody that's done. So it's in the books, and you don't have to worry about the grades. I'm sorry. If understand, if you turn in your work late, I probably won't get to it till Saturday. Sometime later in the week, because I'm busy working with this week. And as I told Elizabeth, yeah, I'll never do that to you guys again or anybody else, where there was, and especially myself, the two different tests in 1 week. I'll spread it out because it was a lot. And I know it was a lot for you in terms of editing and everything else. So I appreciate your hard work. Understanding that editing really goes to your final, because if you have the right information, when you go to do the final, you're doing the same thing on the final that you did there. So you've done it multiple times. The more that you do this, the better you get. I can't tell you I'm a statistical genius. I would never say that. I make mistakes. Okay? There's things I still don't know and still don't understand. There's some deep stuff in there that I still don't understand. And there's some things I don't want to ever teach and have to learn. But I probably could and get it, just as I did this, because I started at 0. And a year later, I'm teaching stats. And 15 years later, heading into my 16th year, I have it kind of honed down. You're not doing everything. Just know that. If you did everything, you'd have a lot more homework. Okay? I'm dealing with basics that I know will get you through your DNP. Your professor may want some more, but if you're running SPSS, especially if you're doing SPSS, everything that you need is right there in front of you. So if they say you needed this, you say, hey, I can go get that. I know where that's at, or I can know where to find it. I can look it up on YouTube, and I can run it. I can have it. I can figure out how to write it up. Because one thing I'm going to show you today is something I pulled from the internet that's fantastic. So there is ways of getting past the idea that I don't know anything to where I know enough to write what I need to write to graduate. It's a difference. Okay? So yes, I could put in a lot more for you to do for the work, but that, I'm supposed to stay within 6 hours. Well, I know we probably mastered 6 hours this week, easy and more. But the rest of these weeks are all one test. Now you've done 2, you should be able to do 1 easier. Okay? So let's get into this week, and we're going to start with the 1 sample t-test. And let's get into here. And you can see that it follows the template. And this one I didn't put in order on purpose, just because I didn't want to. But you see that this first sentence, it has the word differ. The key is you want consistency throughout, but you don't want to say too much. I know I've said that. I know everybody said, well, you beat a dead horse. But you don't want to say too much, and you don't want to repeat yourself. Even though in some things you have to, because it's part of the sentence, but you don't want to repeat yourself on stuff that you don't have to. Plus, that's extra work. Why would I want to do that? I keep saying that over again. The research question for this week is as follows. Is there a difference between participants' insulin scores and a test value of 85? Okay, the purpose of the study is to examine the sample's insulin scores and determine whether its average differs from a test value. But you notice that this lead-in, some of you got marked down because the lead isn't there. Okay? The lead-in is very important. It's not because I want to torture you. It's because APA requires it. It's serration. It's telling your people where they're going. Okay? I'm not going to go through that whole thing. I'm just going to go over the key concepts. This is separated on 2 lines, guys. Most everybody is doing it. Some of you still are not. But these are the words I want you to learn right here. It's will be. Remember, you're dealing right now, in this one especially, you're dealing with, oops, why did you jump? I don't want you to jump. The words right here of, we're not connected. Okay. Of will be. Will be. There is. No, you can't say is because you aren't sure. There will be no difference. There will be a difference. Okay. I know it's something extremely small, but in statistics, a single word can change direction. A single word in the way you word things can create confusion. And that's what we want to stay away from. You want to be very direct. Okay. Here was the significance. I'll get into that in a little bit. Okay. Therefore, the null hypothesis rejected and we accepted the alternative because it was below 0.05. And here's the write-up. And anybody who wants this write-up, just email me. I'll send it to you. Okay. I'll send you this sheet. Okay. You notice that a lot of you on the p-value, it's to the hundredths place, not the thousandths place. All of these have to have hundredths place. The only place we're using 3 is this week, and that 3 is for correlation. Other than that, your M's and your SD's are all 2 places. Your T's and your F's are all 2 places. The only thing is the correlation, which is this week, that is 3 places. And I don't know why, and I'm not even going to think about it. Independent sample, the same thing. This study will examine the difference in coping with an illness. The research for this study is as follows. Oh, I'm missing an F, sorry. Is there a difference between coping in an illness in males and females? Simple, direct. The purpose of the study was to perform an independent sample t-test. Please note, it's a capital I, a capital S, and the T is in italics, okay? And the assumption of normality was met, okay? Now, you understanding that you're saying that we did normality, and that's what we did was normality, okay? HO, there was no difference, okay? And then there was a difference. And then the write-up is basically the same. Now you have 2, okay? Now this p-value was 82. I'm sorry, 42, 42, which is above 0.05. So we go back and the null is rejected. You can say we failed to reject the null. It means the same thing. I kept it simple. It's very directed to the point. Okay. They both work. They're both mean the same exact thing. Okay. And then the word significant. Okay. I'm not going to spend a whole lot of time on this. I'm just kind of laying down a law here. You are not looking for a significant relationship. You're not looking for a significant difference. You're not, when you're doing your hypotheses and you're doing your research questions and you're not doing this, because if so, then you're telling everybody you're not looking for a non-significant. You're only looking for a significant. In your one sample t-test and your independent sample t-test and even your ANOVA, the significance does not go to your conclusion. And a lot of you wrote that in there, but they were not by chance. First off, I didn't ask for that. I asked for the conclusion for the t-test, which is females were higher than males. I don't remember which one. State 2 had higher bets than state 1. The IQ was higher, or I think the insulin score was lower. That's it. That's your conclusion. The more that you add to it, the more that you bring up confusion. And the second part is when you go to do your DNP, the significance level goes to whether you are going to do your hypotheses, not the outcome. So if I'm running a test, and this is the point where I tell you I'm getting emphatic, I'm not mad, I'm not anything. I'm trying to, when I try to make a point, I get really fired up. Okay, fire and brimstone, that's me. Understand that if you put the word significant there, you're leaving out non-significance. We don't look for a significant difference. We look for a difference. We look for a relationship. We look for an effect. If we're asking if we're going to say there was no significant difference, there was a significant difference. Okay. Yes, the word does fit in your hypotheses, but it's not what you want to say there. It's not what you want to say. I had people with the means and then but didn't differ significantly or significantly differed. You've already said that. It's like adding something. It's like arguing something and keep adding on that same thing over and over again. It's not necessary. You say it in that story. If you've written it like I told you to write it, boy, you got it already. You've got everything. You got to, in your discussion, you just put that one sentence. I had people that had 5 or 6 sentences where I had to search for it. It should be very plain and simple. This week, you're dealing with a correlation. Is there a relationship or not? And then I'm going to go over that in a little while, so I'm not going to get into that. So understand, the word significance is only in your write-up, and it's only in the write-up in those areas that it's asked for. Like, I don't think it's asked for this week. It's not even asked for this week. So that's it. So let's talk about the null hypothesis real quick. The null hypothesis was a challenge. Okay. You could say failed to reject the null here. If the number is above 0.05, fail to reject the null or reject the null hypothesis, period. Okay. If it's below 0.05, you're rejecting the null and accepting the alternative, below 0.05. Always remember, if the P is low, it must go. So if the P is low, we're rejecting the null. I'm sorry, we're rejecting the null and accepting the alternative. Because now we're saying no to the thing. We fail to reject the null up here because, again, it's by chance. Okay, so keep that somewhere close by, and that's the easiest way to remember to do it. You can say fail to reject the null hypothesis, or you say reject the null, we reject the null hypothesis, and you're good. Okay, so let's get into the meat and potatoes, which is your correlation. Okay, so let me stop right there. Are there any questions? Well, there's only 1, 2, 3, 4, 5 of us. Okay. Okay, so we're dealing with a correlation. Okay. And that correlation is centered on, hold on, I'm trying to get put this back in and see if it works. A correlation is basically a relationship between two variables. So there it is, it works. And some of you already done it. This should be one of our easiest weeks along the way, because all of us have dealt with a correlation probably in middle school, high school, even elementary school, early in college. We say it a lot of times, well, this is correlated to that. It just means that we are looking for a relationship between two variables, not 10 variables, but two variables. Okay, they have to relatively be independent of each other. It's not like male and female, okay? But like here, we're going to do water today. For example, one of our examples is water and skin elasticity, okay? I will tell a story a little bit later that hopefully will make sense in a real life situation, okay? But it's a numerical coefficient which the extent to which the direction of the two variables are related or associated. So they got to be associated in some way. Okay, male and female are not associated. Water and skin elasticity can be related. All right. It's called the Pearson product moment correlation coefficient. Okay, all the first letters are capped. Okay, let's get into the meat and potatoes now. So they're out of order. Nope. The correlation coefficient, it goes by I'm going to say it a whole bunch of times. Sorry, guys. But it is the small letter R. Oops. Still learning how to use this. Oh, where are you going? Let me erase this real quick. Go back to this one. Okay, so it's basically the letter R. It's a little r. It's in italics. Okay? It means correlation. I call it correlation number, correlation coefficient, Pearson product moment correlation, Pearson R correlations, R. It's not a T, it's not an F, it's an R. Okay. So if you ask on the final, the R, what is the R value of whatever? What is the letter for Pearson product moment correlation? It's R, period. I'm going to start saying this. Understand that when you do your final, I don't know if you're going to be able to do italics. And if we don't know how, it can't do italics, hey, we just don't do it. Okay, I'm not going to stress about that. We're going to talk about, in this case, strength and direction in the next couple slides. Okay. So in this case, as we come to this side and we look at the one, and I've got another slide for this later, and I look at this one, they both are one. Okay. And this is called a perfect correlation. It's a perfect correlation. What is a perfect correlation? All the numbers line up on the same. 1, 2, 3, 4, 5 for the first variable, and 5, 4, 3, 2, 1. It's going to come out being perfect. Okay. If I run two variables against each other and they have the same exact numbers, it's going, and you're going to see this later, it's a perfect correlation. Okay. In your matrix, whichever you're doing, the number 1 means perfect correlation. You're not going to report it because it's usually the same variable going against the same variable. So we take water and skin elasticity. It can't just run water and skin elasticity. It has to run it water and skin elasticity and vice versa. So either way on both lines, you're going to have the number 1. That means it was water versus water and skin elasticity versus skin elasticity. They're going to be perfect. There's no way around it. The other one is going to give you the number, the R value. And remember, it goes to the 100,000s place. So it's period X, X, X. You don't round up anything. It is exactly what it is. Okay. The number here in the middle is no relationship. Okay. So this is a tough one when you're doing your DNP, because if you come up with data and it has no relationship, it's hard. You can still write about it, but it's a lot harder to write about it. If it's a perfect it's really high correlation or a low high correlation or a low correlation, which I'm going to talk about later, there are reasons for it. But this is the point where I want to tell you that, and I'm going to talk about causation. We don't know why. You have it's just like doing your, if you get the same ideas when you did your one sample t-test. You're looking at a number versus a test value. Did you pick the right test value? You don't know. When you pick the two variables, you know what the two variables are, and you know the definition of them. But until you run them, you don't know if there's a correlation or not correlation. Same in your DNP. If you're running a correlation, you could have what you think are great numbers, and when you run it, man, it's no correlation. It doesn't mean there's no answer. That means that they're not related to each other. Now, the question is why? And that's the part you don't know, and that's called a confounding variable. So let me give you this idea. This is a story I've used many years, and a lot of people really understand it. I'm married, but let's say back when I was really young and not as good looking as I am now, we have, I meet a girl, and we begin talking, and relationship is going really well. We're laughing at each other's jokes. We're doing all this other stuff. We're having great time together. That would be called a positive relationship. Okay. So let's say all of a sudden my idiosyncrasies come out and her idiosyncrasies come out, and all of a sudden things aren't going very well, but we're still together. So now that would be a negative correlation. When we break up, now there's no correlation between us. And when you see it visually, this kind of analogy will give you lots of, let's say, understanding of what we're talking about. So on one end, you have a -1, and the other one, you have a +1. All the numbers fall between that line. It never goes above 1. Can't really, because 1 is perfect. Anything above perfect is, I don't know, there's no word for it. And then right then in the center, the closer your number gets to 0. Okay. So if I bring this bad boy up, and let's see, let's use a highlighter this time. Let's make it a little bright yellow here. Okay, so understanding again, we're not connected again. Why are we not connected? Oh, maybe if I did it the right way. Again, perfect on this side, perfect on this side, and then we have no relationship in the middle. So these two numbers are the same. The only difference is this one has a negative sign, but they never put a positive sign over here. So you think about it on a number line, and we think of a number line back when we were in elementary school, and they had it up there on the wall, and they said, okay, -1, -2, -3, that's less than 0, and above is above 0, you know. This one, that line is straight across, and from this 0 right here to this one, and this 0 to this one, okay, are the same. It's the same distance. Just this side is positive, and this side is negative. Okay, so let me give you this little an analogy on this. When we have numbers, and I'm going to keep it very generic, we have two variables, and when we have numbers, and when we actually look at the what do you call it? Your scatter plot, it's going to kind of make a little sense. Okay, when we have two numbers that are positive, both the numbers are going up. When we have a negative number, one goes down and one goes up. Now, I can't tell you which one it is because you look at the scatter plot. Now, the R value only, then of course, this is an R value, and so is this. Okay? When we look at these, we can't tell which one went up and went down. That's where the scatter plot really comes into effect. Okay? Positive side is easy. As assignments come in, grades go up. Everything's great. As assignments come in, the grades go down. The first one is a positive correlation. The second one is not a positive correlation. It's a negative correlation. Okay, very rarely in that sense would I have no relationship at all because somebody's going to do well and somebody's going to do poorly. But as a grouping, it's a grouping of numbers. Okay, any questions so far? Anything that doesn't make sense needs to be repeated. Feel free, pop in. Okay, silence means what we're doing, I'm doing okay. Awesome. All right, here we go. So moving on. Don't know why it's so sensitive tonight. Again, perfect correlation is either +1 or -1. Causation, okay? And I don't know why that's on top of that, okay? In a correlation, we do not know the reason for it. So let's go back to my relationship story. Okay, when things are going extremely well, we can say that things are going extremely well because we really like each other. It's pretty easy. We like doing things together. Now, when you go to the negative side, in this example, okay, there's things that are called confounding variables. So our problems could be because she's fallen for somebody else. She could be secretly dating someone else. Her friends or my friends could be talking bad about her, and that changes my opinion of it. Those are outside influence that go to it. It's not something that you would write about it, but it's the idea that again, we go back to the idea, we don't do things perfectly. We don't have a perfect answer. We have an answer for what's right in front of those numbers that are right in front of us. Now we put that with something else and it might make more sense, or it could be another test or even a demographic that brings it into idea. So I run the test on waterness and elasticity. Okay. But there are other things that help with elasticity, such as losing weight, gaining muscle, firming up your body, those things. Those questions could be answered in a demographic survey that you now can infer that some of the reasons why this could happen because of X, Y, and Z based on what your participants have noted. Could be another correlation, could be another test. It could be something that of a grand conclusion that you're pulling together from the little conclusions that you're doing. Okay? That's the best way I can tell you about causation. Correlation does not mean causation, which means that even though there's a relationship between these two variables, it could mean absolutely nothing. It could mean something, or it could be something that you're not testing. And that's just a generality to the entire process. Okay. Scatter plot, X and Y axis. One variable is the X axis, and one's the Y axis. Okay. So when you're running your scatter plot, there are two things that are really important to remember. You have to know two. I think I can keep it there. Maybe do black. That might work. Okay. We deal with strength and direction. Sorry, direction. Okay. Strength and direction. Okay. So strength you see here, and that's based on the R value. So if I go back to, see if I can get on the screen to get there faster. If I go back to this one, let me clear it out real quick. I go back to this one, 4, 4, 4, negative and positive. That list that I just showed you, okay, is for both. It doesn't matter if it's positive or negative. So our number here was, let's see if a pen's better. Our number here was 0.444. So which one does it fall into? Which one of these does it fall into? Medium. Okay. You could also, sometimes the professor will want moderate. This one might be a slightly. We don't use the word relationship. We use these words right here for the strength. Okay. This one could be strong. This one could be strong. This could be very strong. This could be, what is it? Slight. What is this one? This would be moderate. This would be high. This would be strong, and this would be high relationship. Okay. Depending on what book you're using, depending on what author it is, depending on who it is, you can go on the internet and everyone's going to give you a different way of doing it. I like low, medium, high, and very high because it's extremely easy to remember, but knowing that you may have to do it. So these are strengths. Okay. So it's either negative or positive. So this is the strength. So I've already said that this is medium. So we're going to go medium. And then right here, I've done this one, and I'm going to put positive correlation. Or I'm going to go medium, negative correlation. Now, remember, all this does is the scholar knows two things. They know the strength of it and they can check it with the number that you're putting in the write-up. Oh, yeah, that makes sense. Okay. Positive. It's either negative or positive. But you use words and you use numbers, and then you're going to do the scatter plot and come up with pictures. But you need to have both because both are extremely important, because a positive correlation could mean anything. You need to have the strength and the direction when you're talking about a correlation. One without the other leaves it kind of blank. Okay. And somebody says, why can't you just put the number? Well, no, that's not how it's done. You need to have the words and you have the, basically it's a checks and balances. That's why I say when you start adding extra words, you open yourself up for interpretation very strictly, very directly. When you're talking about it, I say, what is the strength of this number? Well, let's say it's 333. Well, it's a medium. It's above 0.3. Okay. If it's 0.7, it's a high positive correlation. Okay. Now let's talk about our scatter plots. And there's a couple things in here that are real important. Okay, first off is this line here, which we've kind of talked about before. I don't want to spend a lot of time. This is the best fit line. Okay. And it's easier to run this in what do you call it? In sorry. In SPSS and get this type of picture than it is otherwise. Otherwise, you have to kind of draw it out. Okay. But you'll see that it goes down. So we're looking at 100 long jump and 100-meter dash. Okay. And I want you to, and there's a conclusion to this. And basically, it's in the write-up. It's in the write-up. And I'll show that to you later. But understand something. We're looking at long jump and we're looking at 100-meter dash. So as 100-meter dash goes down, time goes down, long jump. I'm sorry. Yeah. Yeah. As 100-meter dash goes down, long jump goes up. So you see these numbers are going up and then these numbers are going down. That's a negative. One's going to be a negative. And, you know, that's exactly how you write it. You would say as 100-meter dash goes down, long jump goes up. Okay. That is the conclusion for the scatter plot, which would be the same as the numbers, but you can see it visually. Now, positive, we know that both of them are going up. So these are the easy ones. Okay. I hate to say that, but I see your hand, Karen. I'll be right with you. On the best fit line, you'll see that as the triple jump went up, the long jump went up. And that's the way you write it. As triple jump went up, long jump went up. No ups, no extras, no significance, no nothing. It's exactly what it shows. Now, I don't know the numbers for these, but in the example I'm going to show you in a minute, you'll see that the numbers are there. Okay. And Karen, what's your question?
How do we know which variable goes to the x-axis versus the y-axis?
You know, it's supposed to be the independent and one and the independent and one and the dependent in the other. But I've been doing it 15 years. I don't have any problem putting in either one because it comes out the same. One's gonna go up and one's gonna go down, and it doesn't matter which one I put them in. I just put them in there, and it works. Because the scatter plot, you'll see the dots. The dots will actually show. The only caveat to that is if you have a few like in water, you're going to see there's very few, but the line is very, very clear. All the assignments, the line is extremely clear for what you're doing to find it out. And in essence, other than you have to post this, if you understand this, it's not really, only if the number's negative do you really need to run the correlation. Why? Because both numbers are going up. You already know the strength in that. So positive is just, you're running the correlation because it's positive. You're showing it as positive, and you're showing how to run a scatter plot right now on that. Only when it's negative, because you don't know which one's going up and down until you do the actual test. Does that kind of make sense? Yeah. When I ran everything, I just put them in there. and I ran them both ways, and it all came out the same. Okay. If you run it the other way, that the line will always go down. Holy Moses. Okay. For some reason, no correlation on here. If you have dots everywhere and you run the best fit line and it's really close to the middle, that means that there's really no correlation, which generally means that your R value is going to be really close to zero, whether it's negative or positive. Okay. So let me get to the next part real quick. You do not have to put this in your assignment, but it's something that, people that are here and the people that watch this, you should know this. Okay. It's called the coefficient of determination. So the idea here is you have a number, and that is your actual number. Okay. Your R value. It says 444. Okay. It doesn't really tell us how much. It tells us if it's correlated in terms of, is it positive or is it negative? But how much truly is it related? And this is the coefficient of determination's job. It's not that hard. If you're running the newer version of SPSS, when you run your scatter plot, it will be on that scatter plot. So it'll be the only thing in the right corner. If you're using the lab, I'm not sure it runs the R2. And basically the R2 is you take your calculator out, turn it, if you have an iPhone, or I don't know about an Android, but you just turn it and it becomes a scientific calculator. Okay. And you're taking that R value and you're squaring it. See, whatever that R, that 444, you put it in the calculator. Oh, let me see. Discard. Okay, if I go to my calculator, which I think I should have, but I don't.
Come on. No, get out of the cat food.
Come on, Mike.
So if I take my calculator, and I got to do a CCC, let's say I point 444, and you'll see this X2 over here. You hit the X2, hit equals, and it gives you the coefficient. Remember, it only goes to two places. So we would say 20% here. We turn it into a percent.
All right. I'm trying to listen to this.
And Mike, Elizabeth.
I muted. So if I go back to the PowerPoint and I start it from there, and it doesn't start from there, sorry. You square it. So in the right corner in SPSS, it's going to give you the R2. If you run it this week in Excel and you use the regression, the R2 is right under the R value. It's the second one on there. And you just have to make it into a percentage. So you take it to the hundreds place and it becomes a percentage. So you can see for the illustrated data, which the R2 was blah, blah, blah. Okay. We did an R2 equals 1.94 and that equals 0.44. Okay. It's 44%. The statistic proportion for one variable explained by the other. The variable points to the quizzes. Okay. 44% of the variability is explained by student GPA. So when we do the other one, it'll kind of make sense. This 194 was the R value. The 44 was the squared value, R squared value. So it's 44% is there. And this will make sense hopefully in a minute. Okay. So again, Pearson R can be squared to derive the coefficient. Is basically the portion of the variability from one variable that can be counted by the variability of the second variable. Still doesn't mean it's perfect. It means that you have an idea. Okay. So in this diagram, okay, the dependent variable is over here, which is y, and the independent variable is the predictor over here. Okay. So think of it this way. In the before is what was happening before in that last slide. The number here was 44%. Oops, I don't want yellow. Sorry. Holy Moses, what is going on tonight? So it's 44%. Okay. So between that first variable, GPA and test scores, let's say, we can say that the overlap in this area right here is 44%. So there's something that there's a reason for it. We don't know the reason, but we're just basically straight out saying, hey, this is it. There's 44% of the variability there. Okay. Any questions?
Hi, Professor. It's Carla. Yes. Can you
Sure.
repeat the 44%? Where did that come from again?
From the sky. No, just kidding. See it right here?
Okay.
We had an R2, and that R2 was 194, and we square rooted it, and it came out to 0.440. We turned that into percentage, and that percentage is 44%, which then falls into here. So the variable of total points on the quiz is 40% of the variability is explained by students' GPA. So in essence, we're saying that 44% of the grades are due to the factor that either they had, if that's a, and again, it doesn't say everything because we don't know if everybody's student GPA was 1.6, but 44% of that, we're saying based on the numbers that we have, 44% of that, of those quiz scores were explained by the student's GPA. So it could have been high GPA scores or low GPA scores. In this case, even with the R value, we know that R value tells us the strength of relationship, and we know it's positive. So both numbers go up, but we don't know the actual. We do if we really dive into it, but it's not something that you have to explain. All it is you're telling the people that there's 44% of the variability is due to the GPA of the students. Does that kind of make sense now?
Yes, thank you.
Okay, great. All right. So let me get into some data. I didn't want to keep that, but that's okay. We're going to minimize this, and I'm going to find. I need the other. Okay, so I have this test, and this comes right from the internet, guys. I'm not going to say that I built this thing. It's a very simplistic representation of a correlation, and then I'm going to show you how to write it up. Okay, but the disclaimer right now is if you when I email this out tonight, as soon as we're done, if you turn it in, I'm just going to say, didn't do the assignment right. I'm going to send it back. Again, I only want the things that are in the instructions, which is the research question, the intro sentence, research question, purpose statement, hypotheses, and then the write-up. Okay, period. Really not need for a discussion this week because it's all kind of encompassed in the one. You can add, copy and paste the other stuff to the bottom. It's not going to be, I want it should be all in there. And I have some people that aren't putting the introductory sentence in there, and you're going to get marked down for that because I'm asking for it. Okay. Okay. So let's see. We have a grouping of people. We're running a little small test in a classroom of exercise students, and we're looking at glasses of water, and then we're looking at the skin elasticity. There's 5 participants. So in this case, I don't know if I can write on this, but the N number, okay, right here goes across to your participants. Now, this is called a matrix. What you see here is a matrix. And again, you'll see that glasses of water see glasses of water here and glasses of water here. And you bring them together. If you've ever done a round robin tournament, you can't play yourself and get a score. It's the same idea. It's a perfect score because each of those numbers, and then you have skin elasticity to skin elasticity. So you're gearing on these 2 boxes. And if you notice, each of these boxes are the same. So you only have to pick one of the boxes to fill out the paperwork, fill it out. Okay. So we have a Pearson correlation score, and that Pearson correlation score goes to what? It goes to an R, that is your R value, and it goes to the third place. When you run it in SPSS, okay, and basically it's running it at 0.01 level, two-tailed. It's just the way it runs it. It doesn't matter. There's two little dots. The number doesn't change. Okay. So what kind of correlation is this? What would we say the strength and the direction of it is?
Strongly positive.
You could say strongly positive. You say very high. It's above 0.08. You could say very high positive correlation. Any one of those works. It's all in how you want to read it, but it's got to say something at the highest level. Okay. All right. Here is your significance level. Now, this is something I want to go over real quick. This is not correct. Your significance level goes to the hundreds place. The 2 brings it down, so it's 0.00. That's it. Don't worry about the 2. We're rounding up to the hundreds place, which is 0.22. Okay? So basically, it's 0. All right? And then, of course, this is the same. Now, this is really cool. In the new one, it pops out and tells you what it is. So the green, you already know it's highly positive. It tells you it's no linear correlation. It tells you positive, negative, or highly negative. It's really cool. Okay? And you see there's glasses of water. It gives you all this information that I never had before. I wish I would have had it when I was doing my master's thesis. That's really cool. So now we move into the scatter plot, and you'll see that the best fit line goes up. So as glasses of water goes up, skin elasticity goes up. And here's our R value. Okay, our R squared, R squared value is 0.97. So 97% of the glasses go to the variability of a skin elasticity ratio. So basically, in a correlation, you basically just laying things out on the table because it's not everything. The conclusion is what you see and what your numbers tell you. But really, your conclusion is more like what your numbers see. Okay? What you see in like your graph. Okay? So I'm going to take this water here and I'm going to move this over and make it smaller. And then I'm going to bring over this sheet. I call it the cheat sheet. And I think it's pretty cool. So understand, we're telling a story. Okay? So it starts right here. A Pearson product moment correlation was computed to assess the relationship between what? What are my two variables?
Glasses of water and skin elasticity.
Great. Your first line is now done. And you'll see it right here. Pearson product moment correlation was coefficient was computed for a relationship between water and one consumed and skin rating of skin elasticity. Now you move into the second part, which is your R value and significance values. Okay. So in this one, here's the same box. Okay. And I've given you what it should look like, except this comes directly from them. Up here, you know you're going to the hundreds place. So it's real simple. Strength and direction. We've already said that. So let's say we say very high positive correlation between the two variables. R as in italics equals 0.985, N equals 5, P equals 0.00. Done. Okay? And I've got it right here. Okay, reference to your scatter plot. scatter plot summary as a result, figure 1. Great, because you're going to put your scatter plot in there. It's figure 1. Okay, so it looks just like this right here. Okay, now report and results in words that people can understand. So overall, a strong positive correlation was observed between water consumption and skin elasticity. Increases in water consumption were correlated to increases of rating of skin elasticity. Okay, so in essence, increases in water consumption were correlated to the increases. There's your increase to increase. If it had been negative, it would have been an increase to decrease. And when you do the negative, you got to read it. It's got to be readable. So when you read it, if it doesn't sound good, you just flip them. Okay? And this is the write-up right here. So if you filled in the blanks with your homework and then wrote it out just as this, you can't miss. The only place you can miss is your conclusion. And then you put your scatter plot underneath it and your homework's done. Research question, I'll come back to that in a minute. Okay, now I have another one real quick here.
Wasn't your conclusion the last statement, the last sentence?
Yes.
Okay.
And I mean, and I wrote that a little elaborate. You could say, as water consumption increased, skin elasticity increased. As dogs eat food, dogs have increases in weight. It's basically the two variables in negative, one's going to increase and one's going to decrease. And when it is positive, they're both going to increase, because I always loved when I got in positive correlations, because I never had to worry about it. I didn't even have to look it up. I ran my scatter plot, posted it with the best fit line, and I wrote it up. It becomes so simple. You just, the other one, you just have to make sure it sounds right. I mean, there's sometimes you listen to, as one goes up, the other one goes down, and you read it, that doesn't sound right. And you put it the other way, and it sounds perfect. It means the same thing. As one goes up, the other one decreased. It's just opposite, whatever sounds good. Okay.
Professor, I have a question.
Sure. Shoot.
For your videos on the modules, it does say for your p-value that you were looking for a less than or greater than 0.05.
Yeah, no, we stay with equals now.
Okay, so stick with your template.
Yeah, if somebody doesn't watch this video and that and put negative below 0.05 or above I'm not going to stress on it.
Thank you.
Yeah, APA changed it, and thank you for reminding me. I'll make sure that gets fixed. But that's one of my more solid videos. I hate changing anything. I might be able to just splice it out, but I doubt it. Probably because it was so long ago. My Camtasia, I lost a whole bunch of stuff because it won't convert anymore. That's how long I've been doing this. So, all right. So if you were to put below 0.05, it means the same thing. APA changed it about 2-3 years ago. So either way, you'll be just fine. Let's see. What else was I going to show you? Oh, I had another one. Hold on. It's over here. Let's see. Okay. Days in ER versus days in a hospital room. Okay. So you can see again, we have a high positive correlation here. This is under 0.001, which means it's basically zero. It's basically zero, because if it's under that, it's going to keep going. It's just 0.000. Make your life easy. We have 24 participants. Okay. So now we look at here. Now here's your R-val. 83% of the between the two variables can be explained by something. And then again, we have a positive fit line here. So as days in the ER went up, days in the hospital room increased. So after they left, they had more days. So the less days they had in the room, the less days they had in the hospital room. But we only deal with our numbers and our direction. So it's positive. So as days in the ER went up, days in the hospital room went up. And basically you do the exact same write-up. All right. I'm not going over SPSS, or I've already got a video out there for Excel. Use the regression and use the video. If you're doing Excel, use the regression video, guys. Whoo! It gave me so much more than trying to do the correlation, because you have to do the t-dist and you have to do all these other steps. It basically gave you everything you needed. You just basically need to run the regression and watch the video of which boxes you need to look at to get the answers to fill in the blanks. All right, so going back to the PowerPoint one more time. And let's see. Let me do it this way. Slideshow from current slide. Again, I'm going over this again. Prepare a title page, okay? Introduction section, 1 paragraph. No, it's just to say introduction at the top. Introductory sentence, okay? You can use the word, this paper will prepare a correlation on the variables, okay? The research question, is there a relationship between X and Z? Purpose statement. Purpose of this study is to examine the relationship of the variables. Null and alternative. This is what I want to finish up on this one. So you'll notice that there's nothing in there about doing an assumption this week. Okay. All your assumptions are met this week. So you did enough work last week, you should understand a little bit about it. But here's the thing. In the null and the alternative, when you're going to answer that null and alternative, there is either a relationship or there is not. Okay? This is very clear cut. It's all in the R value. Okay, so if I have a negative relationship, is there a relationship or not?
There is a relationship.
Negative relationship.
If it's positive, there's a relationship. The only way that you do not have a relationship and a hypothesis for a correlation is if there's no correlation at all. And I can tell you right now, there's a correlation. Okay? Now, to finish that off, you now look at your p-value and go back to what I did earlier, and you finish the p-value. Okay? All right. There's going to be a relationship or no relationship in terms of what you're I'm sorry. Maybe I said this wrong. There's going to be 9 times, all of these are going to have a relationship, but it doesn't completely answer the hypotheses. The hypothesis is answered in the significance level. That is the only place that the significance comes into effect in the write-up. Okay. So although there was a relationship, there was no significance. It doesn't matter. There's either a relationship or there's not a relationship. It's either a strong, medium, positive, or there's no relationship at all. Okay, but even though you have a negative or have no, or I said this completely wrong, I apologize. No matter what the relationship is, it still goes back to the p-value. Okay, still goes back to the p-value. All right. So in your results section, you're going to do the write-up that I have here. Okay. Prepare and export your scatter plot, which you do not have to do anything other than to prepare it and turn it in. Okay. And then kind of like the discussion, you could do the discussion if you want, which is the conclusion. And you can put as one goes up, the other one goes down. Use the one from the scatter plot, or you can just leave it all in your results and you're just fine. Either way, you're going to be fine. Okay. Reason why I put it in the discussion is, again, because I want you to continually hear the word discussion and the words that you need to know as you're going along. And the second part of it is it's easier for me to find that conclusion being in the discussion, and I can say, oh, the conclusion is right, and I can work back from there. Just remember, the correlation is 3 value. It goes to the thousands. Everything else goes to the hundreds. Round up or down. In your p-value, if it's 0.01, it's 0.000. Okay, 0.0. Sorry, 0.0. Correlation is whatever the number is. Everything else goes to the hundreds place, round it up or round it down. I'm sorry. So if it's 0.001, you're going down to 0.0. Whew. All right. Any questions? Anything that was unclear? I take it as silence means that we are good to go.
I have to do the homework and then just
You'll
no,
have questions.
no, it's application.
Yeah, it's not a problem. So as soon as I hang up here and it starts to record, starts to build the recording, I'm going to take that form and I'm going to put it in there. I'm going to send out an email with it. Okay. And just don't turn it in. Make sure you just turn in the paragraph. Because you fill it out just like that. The only place you can make a mistake is in your conclusion. Okay.
You want the scatter plot included as well?
Yeah, put the scatter plot in there. Okay. I know that Excel is just going to give me the dots, and that's fine. I know that if you do the legacy and you're working in the lab, you're probably not going to have the R2 in the corner. Don't stress. And you might not be able to put in, you should be able to actually, let me do that really quick here, since we do have a couple minutes. So we have this scatter plot here. And I don't know if you can put a best fit line in Excel, and I'm not stressed about it for Excel, but over here, it's real easy to do. And basically you just go here and you go to edit, and then it brings up this box. It brings up a chart editor. And then you go to the second line and you slide all the way over and you see the one that has a diagonal line. It's let's see, 1, 2, 3, 4, 5 from the, on the second line. It's 5 from the end. And you see, if you hold it long, it says add fit line at there. Now, when you do that, I already did it. It'll bring up a box that looks like this. This is the craziest thing in the world.
Are we supposed to be seeing what you're doing right now?
No, maybe if I share the screen, it might help, wouldn't it? I apologize. Thank you for saying something. Good. Let me go back here. Close. This has all kinds of lines on it. I don't know if I can get rid of them. So now, can you see it now?
Yes, sir.
Okay, so it's got a whole bunch of lines on there. I'm sorry. But when this box comes up, it's going to show linear. But this blue box will not be, the one that says apply will not be there. All I do is I go up and I click a box and I come back down. That blue box will come out and it'll drop in the fit line. So I wonder if I can. So you hit this one right here. It will bring up the box and it'll say fit line. It'll come up automatically. It'll show linear and you move it to Y or whatever, and you'll see the blue box come up, come back down to linear and pop it in there. And now it'll put in your best fit line and that's it. Does that kind of make sense?
Yes, sir.
Awesome. Awesome. Yeah. So, That's the best way of doing it. If you can visually do it and you have it right, that's fine too. The idea here is that you're running things, and I'm going to tell you what I was given as the guidelines for your DNP is you're going to be running correlations this week and your paired sample t-tests next week. Those are the two most important ones of all of them. Doesn't mean you couldn't run any of the other ones I'm giving you, but those are the two major ones that are usually used. So understanding this one, don't have to understand everything. You got to understand how to run it and get some data and be able to analyze it. And I'm going to tell you, when I have my dissertation students, just like everybody else, want to know everything. No, you got to know what this says and what this says and what this says. And then you have to slow down a little bit and you have to say, what does this mean? What does this mean? What does this mean? Do these all come together? Are they all separate? What is that saying to everything? Does it answer what I'm trying to answer? And that's the real focus behind it. I mean, a paired sample t-test is, in my opinion, the most easiest test to understand. It's almost like an independent sample t-test. I don't know if we do ANOVA next week and then we go into there, it's vice versa, either way. But all of these are, you see, kind of, other than correlation, will scaffold on each other and have some kind of the same properties. But when you're running the paired sample t-test, different than an independent sample t-test, we're not running it against demographics. We're taking a pre-test and a post-test. And we're again now looking at the means, which is better. So taking it to an athletic realm, okay, and we can put it, I can figure out a nursing one too. It's all the same. I decide I have a P, you go back to your middle school days, you had a P class and you were being tested on shooting free throws. Now, a good teacher sets a baseline. So you go out and you have the whole class shoot 10 free throws and they mark down how many they made. Okay. Now I teach for the next 3 weeks. That's an intervention. Could be just like a drug intervention, or it could be something that you're looking at the hospital as something getting better as we make a change, or we're looking at something at one point and at another point. It doesn't matter what it is. Now I teach and I have them practice shooting free throws. At the end of that 3 weeks, I retest them to see if they got better. Did the number go up or did the number go down? Now all of a sudden I have to know my people. So if half of the people play basketball on a team and half of them don't, then the people on the basketball team, I'm looking at them and going, I'm running it against that demographic. I'm running that singular score against a demographic to see if, in terms of the motion higher, was it because they had a lot more experience? They only went incrementally. But the person who made 1 out of 10 is now shooting 6 out of 10. And then I look to see if the way I'm teaching, I'm going back and I'm looking at the way am I teaching, is it good for everybody? Well, sure, it looks like it's good for them, but I got to do something completely different with the other group to help them get better. Now that enacts change, or it enacts the opportunity to lay something on the table to be changed. So this is what you're looking at, especially in when you're looking at correlation, looking at a paired sample t-test. You're looking at, this is where it started, this is where it ended, and why. You already know the who, you already know the what. Now the big one is the why. Why did that improve? What was the changes that were made during that period of time to create that? Okay. This is what should be happening when change is made at a hospital. Change is made in business. Change is made in this. You have a baseline where you're at. You make this change. Did that change increase sales? Did that change decrease the amount of time someone is in the ER? Did whatever drug we added to this patient these patients? Did it decrease their amount of time in the hospital? Did it increase their health to leave the hospital? I mean, just there's so many scenarios to look at. But remember, all of these are just slivers along the way that you're going to have. You're going to put all those slivers together and you're going to come up with the conclusions. You start getting these conclusions right and you start getting those down when you go to your DMP and you start to run this stuff and you look at it and you go, oh, I see that. I see the positive correlation there. Now, why is that a positive correlation? What are the reasons for it? And that's where you get into being able to write what you need to write to finish the paper. And I know that sounds really bad, but you need to understand that you need to start that bad boy and you need to finish it. And the more that you fight that DNP, the more challenges you're going to have, because the biggest thing is that's going to be the biggest thing you've done in your life, and you won't